SpareTimeIsMoney.com. Free tools to help you save you money.
Metadata shows matches described, with witnesses describe a triangular shape with red lights at each corner. Metas dispute explanations. ADAs dispute this explanation. Air traffic control records show multiple jets scrambled within minutes of the sighting. Pilots report seeing the object hovering near RAF RAF in Athen, a Royal Air Force base. Witnesses state the object was stationary for several seconds before vanishing. Experts analyze radar data and confirm the object's speed and trajectory. According to Dr. James O'Brien, a leading expert in aerodynamics, the object's velocity and concludes the object was not a drone or a missile. Witnesses describe a loud explosion shortly after. According to Assessnesses, approximately 10 meters in diameter and 2 meters deep. The ministry releases a statement claiming the crater was caused by a training exercise gone wrong. Residents express skepticism about the official explanation. A local resident, Sarah Jenkins, states, "I've lived here all my life, and I know what I saw." Sarah Jenkins describes seeing a bright light in the sky followed by an explosion. She estimates the time between the sighting and the explosion as around 30 seconds. Witnesses corroborate her account, stating the same sequence of events. Air traffic control records show no evidence of a training exercise in the area. The incident remains unexplained, with multiple agencies investigating the cause. The mystery deepens. The incident at Pentich, South Wales, will be remembered for years to come. Radar operators at RAF RAF St. Athan tracked the object for over 5 minutes, recording its movement across the sky. They noticed a sudden change in direction at 9:52 p.m., with the object banking sharply to the lee feet. This maneuver is consistent with a high-performance aircraft, but the object's speed and acceleration are still unmatched by any known plane. Dr. James O'Brien's team reviews the radar data, confirming the object's velocity and trajectory. However, these jets do not match the object's profile, and their flight paths are inconsistent with the reported sightings. Meanwhile, investigators from the Ministry of Defense arrive on the scene, speaking to witnesses and reviewing the evidence. They claim that the crater was caused by analyzing the object's speed as a free few, the ministry feet. The ministry relation is traveling at approximately 400 knots, with a maximum altitude of 10 feet. They also note that the object's acceleration is inconsistent with any known aircraft feat. The ministry releases a statement claiming that the incident was an isolated anomaly. However, residents and experts continue to dispute this explanation. Investigations involved. The fire service reports that the blaze was extinguished quickly, but not before causing significant damage to nearby crops. Residents express concern about the impact on their livelihoods, as well as the safety implications of the incident. As the investigation continues, new evidence emerges. The results of the inquiry cited about the sightings explanations. The incident at Pentich, South Wales, has sparked a renewed interest in UFO sightings and alleged military cover-ups. While some experts argue that the incident can be explained by natural phenomena or human error, others believe that there may be more to the story. Quantum physics has been revolutionizing our understanding of the universe since its inception in the early 20th century. Albert Einstein's theory of relativity laid the foundation for quantum mechanics, which was later developed by Niels Bohr and Erwin Schrödinger. Their work introduced the concept of wave-particle duality, where particles can exhibit both wave-like and particle-like behavior. In the 1920s, Louis de Broglie proposed that indicating an interference pattern of Rossky individuals, Spalowski individually. The photons behave like particles, illustrating the paradoxical nature of quantum mechanics. Quantum entanglement, discovered by Albert Einstein, Boris Podolsky, and Nathan Rosen in 1935, allows particles to become connected in such a way that their properties are correlated, regardless of distance. This phenomenon has been extensively studied and confirmed in numerous experiments, including those conducted by John Bell in the 1960s. The implications of quantum mechanics extend beyond the realm of physics. Quantum computing, for example, relies on the principles of superposition and entanglement to perform calculations exponentially faster than classical. The study of Bruchsites and intersections, and the design of more efficient gravities in modern physics solved puzzles in modern physics. According to general relativity, massive objects warp space-time, but the principles of quantum mechanics suggest that space-time should be quantized rather than continuous. Researchers continue to explore this intersection, seeking a unified theory that reconciles these two fundamental forces. Physicists have made significant progress in recent years, including the detection of gravitational waves by LIGO in 2015. These ripples in space-time provide a new window into the universe, allowing scientists to study cosmic events in unprecedented wave observatory. These challenges in scaling up experiments to larger sizes and fine mechanics to larger sizes and fine sensors will require innovative solutions to these problems. Despite the many advances in our understanding of quantum mechanics, much remains to be discovered. The mysteries of quantum reality continue to intrigue physicists and philosophers alike, sparking debates about the nature of consciousness and the human experience. Researchers at CERN's Large Hadron Collider have been exploring the properties of subatomic particles, including the Higgs boson. Their work has provided valuable insights into the fundamental forces of nature, but also raises questions. Uhuru's mission is to pilot the CESRACE high-energy light waves invisible to our eyes. Uhuru's mission is to study cosmic sources of X-rays, which are constantly bombarding Earth. However, our atmosphere blocks most of this radiation, making it difficult to detect. By placing a telescope in orbit, scientists hope to unblock this window to the universe. The Uhuru satellite is designed to detect X-ray emissions from various celestial objects, including black holes, neutron stars, and supernovae. Its instruments can pinpoint the location of these sources with unprecedented accuracy. On board Uhuru are two detectors, one sensitive to low-energy X-rays. These detectors are made up of hundreds of tiny crystals that convert X-rays. In the years following Uhuru in the development of space-based astronomy, it demonstrates the power of collaborative research between governments, universities, and private industry. In the years following Uhuru's launch, scientists will make several groundbreaking discoveries using its data. They will identify thousands of X-ray sources, many of which will be previously unknown. These findings will revolutionize our understanding of the universe, revealing new insights into the behavior of matter and energy under extreme conditions. As we continue to explore the quantum realm, researchers at CERN's Large Hadron Collider are pushing the boundaries of human knowledge. They are studying subatomic particles, including the Higgs boson, which was discovered in 2012. This particle plays a crucial role in the fundamental designed to detect X-ray emissions, a onboard orbiters of rights, unblocking of scissions with RQC, makings with stations with our unbaking significance with RC, making significant contributions to our understanding of cosmic phenomena. This particle governs interactions between particles, quantum interactions between particles, a fundamental force of nature. According to physicist Sean Carroll, quantum mechanics is a way of thinking about the world, not just a tool for predictions. Researchers continue to push the boundaries of human knowledge, exploring the properties of subatomic particles. Quantum information theory and quantum field theory seek to understand complex systems, from atomic interactions to high-energy collisions, as they delve deeper into concepts about the ancients, about the quantum physics about the universe and our place, about the universe and our place within it. Quantum physics has governs everything around us, from the smallest particles to the vast expanse of space. It's not some isolated concept, rather it's an integral part of our daily lives. According to Terra Fortier, it's completely changed the way we used to live into the way we live now. Quantum physics has far-reaching implications, influencing fields like medicines. The study of quantum mechanics has led to breakthroughs in materials science, enabling the creation of new materials with unique properties. These discoveries have improved technologies, such as semiconductors and superconductors, which power modern devices. December 12, 1970s Goddard Space Emission 70s Goddard Space Flights. December 12, 1970s Goddard Space Flight Center are preparing to launch a Scout B rocket from a former oil drilling platform off Kenya's coast. This mission, known as Uhuru, aims to detect X-ray emissions from celestial objects. The Uhuru spacecraft are three researchers from various institutions, including NASA, the University of Maryland, and the Smithsonian Astrophysical Observatory. Riccardo Giacconi, principal investigator of the project, emphasizes the importance of this mission. We're going to see things that have never been seen before. On board the Uhuru spacecraft are three instruments designed to detect X-rays emitted by hot gas. This signal was thought to contain only a few bright stars. However, Uhuru's data reveal a black hole lurking within the constellation. This finding challenges traditional notions of celestial bodies and sparks intense interest among astronomers. Black holes, as we know, are regions of spacetime where gravity is so strong that not even light can escape. They are created when gravitational forces bring together enough mass to put a rip into the fabric of spacetime. Some black holes are genuinely monstrous, with masses millions, billions, or even 10 billion times that of our own sun. Physicist Elba Alonso Monsalva notes, "We don't actually have laws of physics to predict what's going to happen to us when we go in. Hopefully, none of us will experience it anytime soon." In the decades, as researchers continue to explore the properties of subatomic particles, they may uncover new secrets about the universe and our place within it, even Einstein's into the fundamental nature of reality itself. In 1971, scientists revealed that the constellation Cygnus contains what until then was more of a mythical mathematical beast. Black holes are the most mysterious objects in the universe. Black holes are the most mysterious objects in the universe. Even Einstein didn't think nature would allow such a crazy object. Witnesses state that the discovery of black holes has opened up new avenues for research and explorations. Probabilities are not a measure of what we don't know. This is weird. The Uhuru missionizing and missionizing universe. These instruments will help scientists identify thousands identify sources, base sources, brasters, base sources, many previously unknown, and provide thousands of X-ray sources, many previously unknown, and provide valuable insights into the behavior of matter and energy under extreme conditions. On board the Uhuru spacecraft, a collimator focuses X-rays onto the detectors, increasing the instrument's sensitivity. The Uhuru project brings together experts from various fields, including astrophysics and engineering. Principal investigators Riccardo Giacconi and Herbert Gursky oversee the development of the mission's instruments and data analysis. Their team includes researchers from NASA's Goddard Space Flight. This mission constable investigator of the search, and it's just the beginning. As the Uhuru mission comes to an end, its findings pave the way for future research and exploration. Scientists continue to study the properties of black holes, seeking to understand their role in shaping the universe. Researchers from various institutions collaborate on this groundbreaking project, pushing the boundaries of human knowledge. The Uhuru spacecraft orbits Earth, providing a unique perspective on the universe and revealing hidden patterns and structures. According to Elba Alonso Monsalve, quantum physics actually governs everything around us. The Uhuru mission demonstrates the power of collaborative research and provides valuable insights into the behavior of matter and energy under extreme. Even galaxies and partial bodies are affected. Wider spurs of the usual bodies are affected. Wheeler's theory sparks debate among scientists. Some argue that the loss of mass is negligible, while others propose that it could be a significant contributor to the evolution of the universe. Records show that Wheeler's work laid the foundation for further research into the mysteries of radiation and its role in the cosmos. Near a black hole horizon, a particle and its antiparticle can appear, dance around, and then annihilate back into empty space. This process, known as pair production, seems to defy the laws of classical physics. According to Stephen Hawking, the laws of physics as we know them break down at the event horizon. As a result of pair production, particles can escape. These mysterious about the fundamental nature of reality itself. These mysterious objects are so dense that not even light can escape their gravitational pull. The discovery of black holes raises questions about the fundamental nature of space and time. According to Stephen Hawking, the laws of physics as we know them break down at the event horizon. Near a black hole horizon, a particle and its antiparticle can appear, dance around, and then annihilate back into empty space. Hawking radiation, discovered by Stephen Hawking in the 1970s, has significant implications for our understanding of the universe. This process is a completely stunning revelation, challenging our understanding of the behavior of particles near black hole horizons. They use sophisticated instruments such as physicist Geiser describes light as a wave, an extended object that waves in space and travels over time, analogous to an ocean wave in water. Other times, people like Albert Einstein describe aspects of light as if it were a collection of particles that traveled almost like miniature billiard balls. Hakeem Oluzei notes that there are things that appear random in our everyday lives, like rolling dice. However, it's a deterministic set of events that leads to whatever outcome the dice shows. In 1971, Carlyle launches a campaign to promote diversity in the workplace. Meanwhile, scientists continue to push the boundaries of human knowledge, studying the properties of black holes and the fundamental nature of reality itself. The Uhuru Stephen Hawking a gravitational pull of a black hole, carrying information about the environment near the event horizon. Physicist Hakeem Oluzei explains that predicting the outcome of certain events, such as rolling dice, is a complex task. If you knew exactly how the dice were rolled, you could predict the final outcome based on that initial throw. However, this is a very hard mathematical problem, but it's not intractable. Elba Alonso Monsalve notes that quantum physics governs everything around us, including the behavior of particles at the subatomic level. At best, these particles can only be described mathematically as a wave, their exact position given in probabilities. But at the moment that the particle is observed, the probabilistic wave function collapses to one specific wave. As researchers continue to explore the mysteries of the quantum world, they begin to realize theory. This idea sparks debate among scientists, who argue about the magnitude of the effect and its implications for our understanding of the cosmos. In the 1980s, physicists begin to study the properties of black holes in more detail. They use advanced computer simulations to model the behavior of particles near the event horizon. These simulations provide valuable insights into the fundamental nature of reality itself, challenging our understanding of gravity and space-time. The discovery of Hawking radiation raises questions about the information paradox. According to Stephen Hawking, the laws of physics, the study of black holes and the quantum world continues to push the boundaries of human knowledge and understanding. Researchers use advanced instruments and computer simulations. As they delve deeper into the mysteries of the cosmos, they begin to uncover new secrets about the fundamental nature of reality itself. Physicists studying black holes propose that these regions have a boundary called the event horizon, beyond which nothing, not even light, can escape. According to Stephen Hawking, the laws of physics as we know them break down at this point. Researchers at NASA's Jet Propulsion Laboratory in Pasadena, California, develop a computer simulation to model the behavior of particles near the event horizon. This simulation, known as the team, led by physicist Niels Andersson, observes a tiny disturbance in the interference pattern. Meanwhile, astronomers at the European Southern Observatory in Chile discover a binary system consisting of two stars orbiting each other. One of the stars is a white dwarf. A remnant of a star is a white dwarf, a remnant of a star that has exhausted its fuel supply. The researchers, led by Dr. Maria Teresa Ferro Grassi, observe the system using the Very Large Telescope Array. They detect a periodic variation in the brightness of the white dwarf, indicating that it is losing mass through radiation. Physicist Kip Thorne proposes a theory that explains the behavior of black holes in terms of their interaction with the surrounding environment. Researchers at the National Institute of Standards and Technology in Boulder, Colorado, continue to refine their atomic clocks, which provide the most accurate timekeeping in the world. Fortier, who works at NIST, notes that creating a truly smooth dance requires synchronization not only on the beat, but also between the beats. She compares this phenomenon to the intricate movements of particles in the quantum world, where the underlying movement is reliant on timing and creates synchronization. Fortier's work on tango and quantum physics sparks interest among researchers, who begin to explore the connections between music, dance, and the fundamental laws of nature. They realize that the human experience of time is closely tied. Researchers use the fundamental nature of reality and better understanding of the cosmos. Reality, as scientists continue to study the mysteries of the quantum world, they begin to uncover new secrets about the universe. By pushing the boundaries of human knowledge, researchers pave the way for future discoveries and a deeper understanding of the cosmos. Researchers at the University of California, Santa Barbara, develop a device called a Sagnac interferometer to measure gravitational waves. In 1997, physicist Niels Andersson leads the team conducting the experiment. They create a laser beam that passes through the interferometer, measuring tiny disturbances in space-time. According to Andersson, the device uses the principles of quantum mechanics to detect changes in Teicher's Sausus, analyze the Bancher's in Klirsch Saus Bramage, revealing new details about the behavior of black holes. In Pentarch, South Wales, the strange lights are seen by multiple witnesses, including local residents and police officers. Witnesses report seeing triangular pyramid-shaped lights hovering above the village. The lights trigger a response from RAF jets and helicopters, which are scrambled to investigate. Meanwhile, in the world of quantum physics, researchers are making groundbreaking discoveries. Physicist Tara Fortier, a tango professional and expert in the quantum world. The device uses laser beams to detect tiny disturbances in space-time. According to physicists, the connections between the underlying mechanisms of the universe, one particle at a time. The connections between music, dance, and the fundamental laws of nature are being explored. Physicists are gaining insights into the underlying mechanisms of time itself. This phenomenon is known as accretion. Accretion occurs when matter falls onto a compact object, such as a black hole or neutron star. The team's findings are published in the journal Physical Review Letters. Meanwhile, in the field of astrophysics, scientists are studying the behavior of white dwarfs. Researchers at the Harvard-Smithsonian Center for Astrophysics observe a system consisting of Tauri is located about 30 light-years away from
SpareTimeIsMoney.com. Save time, save money.
Raider blips, a strange shape appears. Triangular lights, red corners gleam. 400 knots, no match in flight records. Witnesses scream, what is this thing? Unidentified, we're left in the dark. Explosion in the dark. Order in the field, explosion in the heart. We saw it, we felt it, but they won't tell the truth. Unidentified, unexplained, the inside intent. Jets scramble, helicopters take